a second to graph triangle PAT. Here's what I want to do today. Number one, I want to show you guys we can do these without having to do a quadrilateral. Right away, we're going to try to prove a triangle's isosceles. So we can do these coordinate proofs on triangles too. And two is we're going to start talking about how to work smarter, not harder on these. All right, working smarter, not harder. So I think that's the frustration some of you guys feel, and the stress is you have to write so much stuff. Not all the time. All right, let's prove it isosceles. Prove it isosceles. First question I have for somebody is, well, what makes a triangle isosceles? Oh, 3. Eva, what makes a triangle isosceles? Two sides are angles. Probably not going to do angles up on a graph, right? So I'm going to do two sides. Just by looking at, and I haven't filled in the other side for a reason. I didn't forget about it. But looking at your triangle PAT, what two sides do you think are probably going to be the congruent ones here? PA and AT. All right, what formula do I need to prove two sides congruent? 1? Meg, what formula do I need? Distance formula. So here we go. Whoa, easy on that. I don't think I need that size pen, huh? Let's try that one. All right, so I need distance. So in your groups right now, go ahead, find the distance of PA and find the distance of AT. No need to simplify the radical at the end. Go right ahead, talk with your group, make sure you guys are all in agreement before somebody gets called on. All right, let me know when you got one of your distances, please. 3. Eva, got a distance for me already? Good. Square root of 130. Everyone should have got square root of 130 underneath. All right, square root of 130. And then, yes, AT also should be coming out to be the square root of 130. You should, if you want to know if you went wrong somewhere, PA, you should have 11 squared and 3 squared. And then AT, you should have 7 squared and 9 squared. Both giving you 130. Next up, you guys know the deal. After you show a formula, what did you just learn from it? So what did I just learn about PA and AT here? 16. What do we know about the two now? They're congruent. PA congruent to AT because distances are equal. And then we could say triangle PAT is isosceles. Another great spelling word there, huh? Somebody want to tell me why we know it's isosceles? Oh, 7. Why is this bad boy isosceles?
Because
two sides congruent. Done. Any issues getting a triangle to be isosceles using coordinate proof? Next part, part B. This is where you struggle. I know this for a fact. This is where you guys struggle. Find a missing coordinate that makes this into a parallelogram. So put point R somewhere, so this is a parallelogram. Let's make it easy on ourselves. What do you know about opposite sides of a parallelogram? Congruent and parallel. So that means to me that AP and T, wherever I put it, R, should have the same what if they are parallel? Slopes. Yeah, they should have the same slopes. So in your groups right now, quickly calculate the slope of AP. Go ahead. Find the slope of AP, rise over run. And what did you count? Up and over how many? AP. I get it. You guys don't know. 18. Up and over how many?
11, negative 11 fourths.
Negative 11.
Fourths. Thirds. Oh, I graphed it wrong.
Come on, Claire. You're better than that. All right, so T and wherever I put R should also be negative 11 over 3. Hey guys, where do you think I should start counting? Where should I start counting up here so I can go up 11 over 3? Point T, and we're done. All right, don't make this difficult. Up 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and over 3. Now, when I say over, it's got to be negative 11 thirds, so I got to go to the left 3. 1, 2, 3. There it is. There's point R. And it is, what's that point there? 2, 9. So part B is 2, 9. That's it. Just use the slopes. Move. Go ahead.
Would you just write that like 2, 9 up there?
Yeah, that's fine. Or part B, 2, 9. It's really not part of the proof. Okay. And then part C. Now prove to me this is a parallelogram. Prove to me it's a parallelogram. Now look, this is what hey, this is my little main idea here today. Working smarter, not harder. What would be the best method to prove this a parallel? I know we have so many methods, but what's the best method based on some work we already done? Didn't we just find the slope of AP? And don't you already know the slope of TR because you've graphed R yourself? So why don't we just prove this using opposite sides parallel? We already know 2 of the darn slopes out of the 4. So why would I go find distances over again? All right, let's not go that route. Work smarter, not harder. You already have some info. So the slope of AP already calculated, negative 11 thirds. The slope of RT already calculated, negative 11 thirds. Now all you have to do in your groups right now is, what about the other 2 sides? AR and PT. Go ahead, make sure you guys match up at the end. AR and PT. All right, what'd you get for the slopes? AR and PT are both 22? 4 over 6. If anybody reduces down to 2/3, great. I'll accept it. So there we go. Negative 11 thirds and 4/6 are my slopes. All right, tell me something about the sides then. What do I know about the sides? 12, what did we just learn about the sides? AP and RTR? They're parallel. And the same thing can be said for AR and PT. Hopefully we're getting more and more comfortable what I need to write. Because, why, Brendan? Slopes are equal, or same slopes. Perfect. And then everybody can write the last line that this bad boy is a parallelogram. Don't call it a bad boy, but parallelogram part is a parallelogram. And real quickly, just so I know we're solid, why is it a parallelogram? 11, why are you going to write it's a parallelogram?
Both pairs of opposite sides parallel.
Good job. Questions from you guys? We're all good. We can do these on triangles. All right, something a little different again on the next one. Oh, you know what just reminded me? Going to the next problem. How you came so close yesterday. So close, so close. It still makes me smile. Oh, that was awesome. So everyone's looking at this and they're like, oh, this is a trapezoid question. He's going to ask me to prove a trapezoid. Nope, not at all. Here's what I want you to do. Yes, I have quadrilateral ABCD, but I'm not doing anything with it. I want you to create a new quadrilateral for me called MNPQ. How do you create MNPQ? You take the midpoints of ABCD, all 4 sides, and connect them. That's how we're going to make this new quadrilateral. So that's your first job. You're going to come up with point M in your group, which is the midpoint of AB. Ooh, need the midpoint formula. Hopefully we've reviewed that in our groups. If not, we're going to talk about it. Then you're going to find the N, which is the midpoint of BC. And then P and Q. So you're going to find the midpoint of all four sides of this quadrilateral and connect them to form a new one. Go right ahead in your groups. Figure out. I know we've reviewed midpoint already, but oh boy, here we go. Questions have already started. All right, check your midpoints as I put them up here now. Point M, everybody. Point M, negative 5, 5. Point N, 0, 3. Point P, 2, negative 4. And point Q, negative 3, negative 2. If you haven't done so, you probably want to graph them. Okay, all ready to move on? Okay, again, here's another example of working smarter, not harder. You're about to prove in a parallelogram, correct? And I realize from our last proof, many people probably want to do opposite sides parallel, use slopes. Wait a second though. Can we please just get a little sniff of part B, what it's asking us to do? We're going to also have to prove it not a rhombus. And what's the way we're going to prove it not a rhombus?
All sides aren't equal.
Yeah, show all sides aren't equal. And that's what formula? Distance. So let's think about it. Are you going to do 4 slopes and then 4 distances? 8 different formulas, working harder. Or what might it be smarter to do right from the beginning to prove it a parallelogram? Just show the distances right from the beginning. So let's do opposite sides congruent instead. So I only have to do 4 distances and I'm done with the problem. Everyone see what I mean? Working smarter, not harder then. If you want to show all 8, that's fine. 4 slopes, 4 distances. Be my guest if you're more comfortable. But for me, less work the better. Let's do distances. So MN, QP, MQ, and NP. Go ahead in your groups. What's the distance of each? Throw out a distance real quick here to make sure we're on the right track. Square root of 29. Yeah, MN and QP. I got square root of 29 for both those two. Anybody want to toss out MQ or NP? 53, yep, square root of 53. Good job, everyone. So now we can say in step 2, MN congruent to QP. And on the opposite side, MQ congruent to NP because distances are equal. And then you guys know it's a parallelogram. Right, now we could say it's a parallelogram. MNPQ is a parallelogram because opposite sides congruent. Now, see what I mean? Now we don't have to do a thing now. Do we already know it's not a rhombus? I don't have to show a thing. I don't have to go back, show 4 more formulas. All right, we can now say one step, and that's all it's going to take. MNPQ is not a rhombus Because, and I'll turn this over to you guys. Why isn't it a rhombus? Oh, 8.
Because none of sides are congruent.
Done. Perfect. And if you want to do parallel lines here and then congruent here, distances, that's fine. All right, I'm never going to knock you. Whatever you're comfortable with. I know a lot of you want to get it done and over with as soon as possible, so that's what I'm trying to provide here. One more. Well, oh, Paul, sorry. Yeah.
Did do that? That was the first question. Could you just prove like MN and MQ?
Yes, that's fine. As long as you show me 2 sides aren't equal. You didn't need to really do all 4. All right, good deal. One more here. I want to get away from a quadrilateral. How about a right triangle? Can you prove a right triangle on a graph? Oh. Go ahead, fire that baby up, ABC. Can we prove it's a right triangle? What do you think? Can we do it? Do you think we can prove it a right triangle? On a graph? On a graph. Talk to me then. How? How can I show it's a right triangle on a graph? What's up, Avery?
Slopes.
Okay. Where's that going to get me to? Keep talking. Keep talking.
Well, if you find like, what is it called? The negative reciprocal side can tell you that it makes a perpendicular line and right angles are formed by perpendicular line.
So I need a right angle.
Yeah.
And you get that from perpendicular lines, which you get from negative reciprocals as slopes. Perfect. Now another advantage of graphing. Can everyone see where I probably will have that right angle in my triangle? So I don't have to waste time doing slopes of all 3 sides. Where's that right angle probably going to be? Angle B. So I should only probably do the slopes of what's 2 sides here. AB and BC. Go! Go! AB and BC. Quick, you do that one quick. AB, what do you have? +1. What about BC? Oh, -1. They look like a little negative reciprocal action there, huh? All right, what do you think your step 2 should be then? Hi, Lauren.
AB is perpendicular to BC.
I'm doing well too, thanks. AB perpendicular to BC. Perfect. Somebody else want to take over for her because I know she's a good student, but obviously she knows why. Caitlin? Slopes are negative reciprocals. Ooh, reciprocals. What do you think? Good spelling bee word? I don't know if that one's on the list, if that made the list. I think so, maybe. I think it does. Keep thinking in your mind like we're doing an actual statement's reason. So they're perpendicular. So what happens next? Paul?
Angle B is the right angle.
Okay, yeah. Angle B is a right angle because perpendicular lines form right angles. And then now I have a little right triangle on my hands. Angle B is a right angle, yeah. So triangle ABC is a right triangle. What's a good reason? Why is it a right triangle? Speak to me in your own words. I don't need something fancy. 12 in your own words. Yeah, because right triangles have right angles. Look at the bottom of your page. Those are from the review. Now, I don't think the packet pages match up. I actually think it starts on page 54, but you're looking for those numbered problems. They are all review. They're not. I think the last one's a coordinate one, and that is it. It's all review. We are starting review for the test now. Where are the answers to these? Where are the answers usually to all the review questions? In the packet. You're not going to find them on Classroom. All right, they're in the packet. So go ahead, get after it. Let's get going. Those aren't textbook questions. Those are in your packet review questions. So go talk it over with your group, because you're going to see right from the first one, that's a day one question. All right, the first question I'm having you do is a day one question. Come on. Check your answers in the back of the packet.